All right, students, today you are assigned this worksheet here called How to Read a Phylogenetic Tree. So scientists use phylogenetic trees to group organisms by how similar or different they are from each other. Or in other words, it's just a tree to show the relatedness of these different species. Oftentimes, these trees are created using genetic sequences. So we actually look at their DNA, and organisms that are more related to each other have DNA sequences that are more similar, and organisms that are further apart in evolution have more different DNA sequences. So that helps us kind of identify where they should be on the tree. The organisms all the way on the right of the diagram or on the outer nodes or tips of the tree branches are considered to be present-day organisms. So that includes our nematode up here, fruit fly, zebrafish, frog, chicken, mouse, and human. These are all animals that are living today, or present-day organisms. These are the organisms that we have information about. Scientists have the DNA sequences, and they can use those to create the tree here that we see. Along the lines are an unknown number of inner nodes that represent organisms that are ancestors to the organisms. So for example, this square here represents the common ancestor for the chicken over here, as well as both the human and the mouse. So this individual is our common ancestor. So there is this aspect of time on our phylogenetic tree. So this is a long time ago, and as we move this way, this is current day. So those are just a couple things to keep in mind. And then our lines represent common ancestors as well. So if we're at this point in the line, or this point, or this point, or this point, all the way back, those are all the ancestors of the chicken. And then same here with our mouse, these are all the ancestors of the mouse. This, again, is another branch that represents the common ancestor of our mouse and our human. So, some things to keep in mind. Go ahead and flip to page 2 here. We're going to look at the questions and then go through this together. Then you will go through pages 3 and 4 on your own. So, the number 1 here says, color the line that represents all ancestors of the frog green. So I'm going to change my color to green here. It says, but only the ancestral line not shared with other organisms. So we want the ancestral line, but only the line that is just for frogs. So our frog is over here. We're going to start here. We're going to go all the way back on this line, all the way back to here. And those represent all the ancestors of the frog that are just to the frog. If it didn't include this last line here that says, but only the ancestral line not shared with other organisms, then we could go all the way back like this. But since these guys back here also are the ancestors to chicken, mouse, and human, we're not including those for number 1. Okay, number 2 says, circle the last common ancestor of the frog and the chicken. So frog is here, chicken is here. Where was their most recent common ancestor? Well, to do this, we're basically just finding where the lines intersect or where they meet up. So if our chicken comes back here, it's going to meet up with our frog that comes from this direction. So this represents our common ancestor right there. So we're going to put a circle there. And that should be it for number 2. Okay, number 3, put a box around the last common ancestor of the human and the chicken. Okay, so we got our human here, we got our chicken here. Again, we're going to see where the lines meet up. So chicken comes that direction, human comes this direction. They meet up right there. And it tells us to put a box there, so we'll put a little square here. Okay, so that's their common ancestor. And again, there's this aspect of time. So this is modern day over here. So, some time ago, our ancestor was around and we are the descendants of them. Okay, number 4, put a triangle around the last common ancestor of the chicken and the zebrafish. So we got our chicken here, zebrafish up here. We're going to see where they intercept. There's the chicken. Oh, there's the zebrafish. So we'll throw a triangle there, and that's their common ancestor. Okay. Number 5 here says, color the line that represents all ancestors of the human red, including all shared ancestors. So we're going to go all the way back on this one. I'm going to change my pen to red. And we're looking at the human line. So we're going to start here. We're going to go back. Ooh, okay, now we're going with the mouse, but we're just going to keep going back because we want all ancestors, even the ones that other species share with us. Cool beans, cool beans. All the way back here. Great. Okay, that was number 5. Number 6 says, color the line that represents all ancestors of the fruit fly blue, including all shared ancestors. Fruit fly is going to be up towards the top. So we're going to color this line blue, and it wants us to include all shared ancestors as well. So when we get to the red line here, I'm just going to draw the blue next to it so that we can see both of them there. Okay, number 7. Out of the mouse, chicken, frog, and zebrafish, which one is most distantly related to the human beings? Okay, so mouse, chicken, frog, and zebrafish. Which one is most distantly related to us? We're all the way down here, right? Well, you might think, okay, zebrafish is further away when we're just looking at this linearly, right? So it must be the zebrafish. Well, that is the correct answer. It's the zebrafish, but there's a different reason. It's not necessarily because they're further away from us on this lineup, but it's because we share a more distant common ancestor with them. So like our mouse, our common ancestor with the mouse is right here. With the chicken, it's this square. With the frog, it's this circle. And with the zebrafish, it's this triangle all the way back here. So the reason it's the zebrafish is because our ancestor, our common ancestor with them lived a long time ago, or the longest time ago. So of the mouse, chicken, frog, and zebrafish, which is most distantly related, we'll say the zebrafish for this one. Again, because our ancestor lived a long, long time ago with the zebrafish. Without this tree's information, which organism would you guess was closest to human beings? Explain your answer and why. Ooh, yeah. So we don't have the tree here. Just based on these animals, which one do you think you're most closely related to? Hopefully you're able to look at the characteristics of these different animals, and that can help you decide. So like you could say eyes, right? We have eyes, so do mice and chicken and frogs and fish and flies, but our nematode up here does not have eyes. So they're probably a little more distantly related. So that's an example of looking at different characteristics. If we get really specific, I would say the mouse here shares a lot more characteristics in common with us than even like the chicken or the frog, right? So mice are mammals. We are mammals. They are warm-blooded. We're warm-blooded. They have hair or fur, and we have hair or fur. So some of the characteristics really line up and help us understand that, yeah, we are really related. So we'll say the mouse and why. Say we both have hair. You could even say we produce milk. That's characteristic of mammals. And we're warm-blooded. Those are just some examples. You could include other ones if you can think of them as well. Okay. Think about what the last common ancestor of the zebrafish and the human might have looked like. Describe your answer below. So our human is here. Our zebrafish is up here. And their common ancestor is the triangle here. We already identified that. So the question is, their common ancestor, this triangle, what did they look like? This is our ancestor. This is who we descended from, which I think is so cool. The question is, really, are they more fish-like or are they more human-like? Because our fish does not branch as much in our tree, we're going to assume that our ancestor looked more like the fish. And then with our human, because we have a frog that branches off there and a chicken and a mouse, all these branches make us think, okay, these ancestors over here were evolving really drastically over this time. And so through that, our human has ended up just looking really, really different than what our ancestor was back here. So we would assume that our common ancestor, the triangle here, was more fish-like than it was human-like. So we'll say fish-like because more recent ancestors have different characteristics. Right? So we can see like this common ancestor with our mouse and our human has evolved different characteristics that are unique to just mice and human. Or same with this common ancestor has developed traits that are unique to the chicken and the mouse and the human. So all of these ancestors all along the way have been evolving. Okay. Hopefully this gives you a good feel for how our evolutionary tree works. I'm going to have our sub pause the video here and let you work on the next 2 pages. So the next page here is going to have you identify an out group for number 10. The out group is just the group that is most distant from the other groups. And so for number 10, you're going to be looking at this graph here or this tree here. So tell me which one is the out group. Number 11 wants you to look at the closeness of each organism. And it asks you specifically with the Dumbo octopus. And it wants to know which organism is most closely related to the Dumbo octopus. And hopefully you can use your understanding of common ancestors to identify number 11 there. Then on our last page, it's going to have you identify clades. Clades it's basically just a word that means group. Okay, so it's saying right here, this is a clade or a group of animals. And you can see they're both octopus. Okay, so this is the octopus group or the octopus clade. Over here, we've got the squid and the nautilus. This is going to be like more of a squid-like clade. But we could group all of these together and say these are cephalopods. That's their group or their clade. Okay, so we're just grouping animals here. So for number 12, it says clade containing herring and sardine, but no others. Oh, our sardine is here. Our herring is here. So we're going to group these off, and you can just put a box around those. And I think it says in purple specifically. So go through those. See if you can just box off our different groups or different clades. Okay, this is the reading phylogenetic trees worksheet. I'll give the sub the answer key here so that you can double check with her what the answers are. When you're done with that, you can start working on this next assignment here called the phylogenetic tree practice. One thing I want to point out on this assignment here is this assignment also has traits listed on the tree like this. So we've got jaws, lungs, claws or nails, feathers, and fur. So the thing that you need to know here is that time is moving up like this. Okay, so this common ancestor back here lived a lot long ago than this one or this one or this one, right? And as we move this direction, we see the evolution of these different traits. So lungs evolve right around here, which means everyone downstream also inherited lungs, right? So like this. And I think that's the first question there. How many organisms on the cladogram have lungs? Well, we can see 1, 2, 3, 4, 5, because everything downstream from our lungs also inherited that trait, right? Yeah, I think that's all I want to go through there. I'll also leave the answer key for this assignment with the sub. If you have any questions, you can go through that. But have a great day. Hopefully this made sense. And I will see you guys the next week.